Good morning, students. Myself, Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. Students, superconductivity is an important topic in MSc Final Physics first paper. In my previous lectures, I have discussed about superconductivity a lot in very detail. Today, from revision point of view, I am going to discuss some important and basic concepts of superconductivity. So, to proceed, first of all, I am going to tell you what are superconductors and what is the phenomena of superconductivity. This was initially discovered by K. Owens when he discovered that when mercury is cooled and he observed its resistivity and he found that on cooling it at a particular temperature it loses its resistivity. That means resistivity becomes zero. Resistivity zero means conductivity infinite. This phenomena is known as superconductivity. That means the absence of electrical resistivity. This makes almost infinite conductivity, and these materials which exhibit this phenomena, they are termed as superconductor. So a superconductor is an element, or it can even be an alloy, which when cooled below a particular temperature, then these materials will lose their resistance. Now, what is transition temperature? In my definition, I have stated that there is a particular temperature below which the material has zero resistivity. This particular temperature at which the resistivity becomes zero, this temperature is termed as transition temperature. So we can define the transition temperature as a temperature at which the material changes its behavior from a normal material to a superconductor. It is termed as transition temperature, and it is also termed as critical temperature. An important phenomena in the field of superconductivity is Misner effect. I am going to give you a brief review what is Misner effect. We have a superconducting material and we place this superconducting material in a magnetic field. Then it is observed that in the interior of this super material there are no magnetic field lines. That means the flux lines, they are pulled out of the superconductor. So we can say that inside the superconductor B equal to 0. So these material exhibit perfect diamagnetism, and this absence of magnetism inside the superconductor is termed as Misner effect. These materials also exhibit an important another phenomena, which is the isotope effect in superconductivity. As superconductors have a temperature Tc, transition temperature, it is observed that this transition temperature, it depends on the isotopic mass, and the relation between Tc and mass is Tc is directly proportional to 1 upon m raised to the power alpha. Here alpha is termed as isotope effect coefficient. Next important question is, what is SQUID? SQUID means superconducting quantum interference devices. In this we take two Josephson junction, and these junctions, they are mounted on a superconducting ring, and this combination form a interferometer. These squids, they are based on the phenomena of flux quantization, and the total magnetic flux passing through the superconducting squid, it is quantized. Next important question is, define Cooper pair. We know that the basic cause of superconductivity is the formation of Cooper pair. We have two electrons. These pair of electrons, they interact with each other through a virtual phonon. That means there is an interaction between electron, lattice and an electron. The two electrons which are taking part in the interaction, they must have equal and opposite momenta and spin. That is, if spin of one is plus half, other should have a spin minus half, up and down spin. Momentum plus mv, other should have a momentum minus mv. And these two electrons, they form a pair which is termed as Cooper pair. And the condition for the formation of Cooper pair is that this electron phonon electron attractive interaction must be greater than the electron electron repulsive interaction. Next important question is, we must know what is the coherence length. It is the length up to which these two electrons, they remain correlated so that they are forming a pair which we have defined as Cooper pair. Now, what is DC Josephson effect? Before discussing what is DC Josephson effect, I am telling you something about tunneling. I am considering that we have two metals, and these two metals, they are separated by a insulating layer. As we are well familiar that an insulator is a device through which no current flows. That means a free electron in first metal cannot pass through insulator so as to cross this junction and move over to the another side to the second metal. Similarly, the free electron of second metal cannot cross the junction and it cannot move to the first metallic material. That means this insulator is acting as a barrier. If this barrier is thin, then electron flow can happen. This is the process of tunneling. Now, what is DC Josephson effect? In order to explain tunneling, I have taken two metals separating by an insulating layer. In Josephson effect, we have to take two superconducting materials which are separated by an insulating layer. This insulating layer is generally made up of oxide, and we are taking that this thickness of this insulating layer which is forming a barrier is very thick. It has been observed that a DC current flows in the output in the absence of any external applied source. So this effect is termed as DC Josephson effect. The next question is, what is AC Josephson effect? As in the first case, we were having two superconducting materials. Similar in this case, we are having two superconducting materials and they are separated by an insulating layer. In the earlier case, there was no voltage source, but now we are applying a DC voltage source across the junction. Then in this case, there will be an oscillating output current. That means in the output, we have an alternating current. And this effect is termed as AC Josephson effect. This effect is very useful effect and it has been used in the determination of E by H cross. Now, as we have stated that below a particular temperature Tc, the material will be superconductor. That means by the variation of temperature, material can change from a normal to a superconducting material. Now we will see the effect of magnetic field. In order to see the effect of magnetic field, I am going to define the term critical magnetic field in the superconductor. Let the temperature of the material is below Tc. Then we have this superconductor and we are placing the superconductor in a magnetic field. Then the minimum value of magnetic field that is needed to destroy superconductivity is termed as critical magnetic field. And it is denoted by Hc, and the relation of critical magnetic field is Hc is equal to H0 1 minus T upon Tc square. Here Hc is the critical magnetic field at a particular temperature T. H0 is the critical magnetic field at absolute zero and Tc is the transition temperature of the material. So this is the relation that critical magnetic field has with temperature. So students, these are some basic important questions that you must know about superconductivity. Thank you students for watching.